At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
All right, welcome everyone to the Simio Solution Series, July 16th today. Today's session is called Work Smarter, Not Harder, a data-driven approach to modeling labor. My name is Dan Vasilini. I'm the VP of Global Sales over here at Simio. Doing most of the presenting is going to be Chiara Bondi. She's one of our solution engineers, and you can see both of our email addresses there. So I'm going to put these up now. I'm also going to put them up at the end in case questions come in that you don't get addressed today. I'll talk about that as we go, but there's our email addresses if you want to jot them down now. Otherwise, you will see them again at the end. Also, on the left side of your screen, you see that QR code. I mention this every time, but if you are new to the Solution Series, we publish this QR code. I ask that you scan the QR code and give us feedback on today's session, as well as any suggestions you may have for future sessions. We're always looking for input, and we're always happy to incorporate something that someone requests into a future session. And I'll talk about future sessions here shortly, and now would be a good time if you are interested or have a topic to please get them to us. All right, a few housekeeping items before we get started today. Today's session is being recorded for replay purposes. Please be aware of that. You will be on mute during today's session. If you wish to ask a question, you will see it's called the Slido polling area in the WebEx panel, in the attendee panel. You can type your question in there. If you do type your question in there and you accidentally close the panel by hitting the X, just simply reopen the app and you'll be back into it. It's a little bit tricky sometimes when you go to ask a question and you hit submit and then you hit the X and it closes on you. Just reopen the app and you'll be good to go. As I mentioned, today's session is being recorded. If you do wish to rewatch this session or any session we've done in the past, a little bit of new directions here. So we have modified our website slightly since our last session. The Solution Series are now going to be under the Learning tab. So just a quick picture there on your screen. You'll see the Learning tab highlighted in orange or circled in orange. There is where the Solution Series webinars are at. Any of these sessions we've done in the past, they're all out there. So Chiara, I think, is going to refer to a prior session that she had done. And if you wish to go back and watch that prior session, just simply go to simio.com. Learning tab, drop that down, you'll see the Solution Series webinars, and you can go and watch any of the sessions there. Today's session is scheduled for about 60 minutes. Chiara will probably be presenting for about 40 of those 60 minutes. We will leave some time for Q&A. If questions come in during today's session that are relevant to something we're talking about, I will try to break in or interrupt Chiara, or if there is a break in her presentation, I'll try to ask questions that are relevant at that point in time. If the question is more generic in nature, I will bring those up at the end when we open up for Q&A. As I mentioned earlier, upcoming Solution Series. So right now, this will be our last session here for, quote, the summer session. We generally do not do a session in August because of vacations and everything like that and time off. So we will not be doing a session in August as normal. We will kick things back off in the fall, probably mid to late September. So right now we are working on our fall schedule for September, October, November. We'll have those published here shortly. And as you get emails from Simio, either in the scoop or recognizing these webcasts, you will get an email as soon as we have the calendar published for the next sessions that are upcoming. And as I said earlier, I'll bring it up one more time, the QR code. If you are interested, please feel free to click on that QR code or scan that QR code. And in there, we ask for feedback or suggestions. You can give us feedback there and suggestions. All right, that'll be it for me. So I want to thank everyone for attending live today. If you're watching this on recording, thanks for coming in and watch the recording. I will turn things over to Kiara. As I mentioned, I will bring up mine and her email addresses again at the end. So if a question does come in that doesn't get addressed, you will have the opportunity to reach out to one of us directly. Once again, thank you for attending, and Kiara, the floor is yours.
Awesome. Thanks, Dan. Hello, everyone. Thank you very much for joining. As Dan mentioned, today we're going to be looking at workers. Specifically, how can you add worker requirements to your different machinery, worker requirements for certain tasks? How can you add schedules? And we're even going to be diving into how can those schedules potentially be modified during the model run. There can be changes that occur where one of your workers goes off shift and you're going to need another one to come on and add to their shift, potentially change schedules around, etc. Because this is real life. Things happen, and we need to prepare for these unexpected changes. And so how can we start to look at these specific modifications and the specific behavior in a simulation setting? So we're going to spend all of our time in the Simio software and building upon a previously built model that some of you may recognize, and if not, we will dive into it shortly, spending all of the time in this conversation. And again, if questions come up, please submit them and we will address them accordingly. So with that being said, I will go ahead and start sharing my screen. Perfect. Dan, can you just confirm for me that you can see the Simio screen?
You're good to go.
Awesome. Perfect. So as I mentioned, some viewers might be aware of this specific model. This is the one model that was used in our 2 of the 3 episodes of our 3-part series of the building blocks of the Simio building blocks. So this is for building blocks 1 and building blocks 2, where we start by going through all of the different steps from beginning to then more advanced analytics on how to build your first model. This, as Dan mentioned, is recorded and is available on our platform. So if you've missed any of those sessions, I strongly recommend you go and take a look at that. But what we're going to be looking at is in this model, we have all these different stations. So let's imagine we are in one of our manufacturing facilities where we have different orders coming in, going through all the different machinery, different routing requirements, different tasks. But this isn't a super high-tech, advanced, fully automated system. We have employees. We specifically have workers that are going to be required at maybe certain stations or certain areas that are going to need to complete certain tasks. And so the question becomes, well, how can I not only model the worker requirements and add that constraint of someone needs to be here to do this, but how do we then add a more realistic detail, adding worker schedules, maybe adding more movement across the system, the shift of schedules, etc. So the first thing I kind of want to note is that the worker object is the one that's already loaded in the library. And in all of its properties is where we can start to define a few of these different properties, such as defining what its capacity is, if it's one that's fixed at a certain value, either off shift of a capacity of 0 or on shift capacity of 1, or it might work on a specific schedule. And we'll look at how to add that schedule later on. We can also modify a few of the other properties to maybe mimic realistic behavior, such as speed, what kind of paths it can move, and how it selects its specific task allocation. Since every single time that an entity requires a worker to do something, those get added into a queue of a list of tasks that the worker needs to perform. And we can start playing around with some of the properties to sort them and figure out, okay, how does the worker want to move around and complete all of these? But now that we have our little worker implemented in the system, we want to understand, okay, how can a worker be added to a specific machine or the worker requirement? And if we click any of our servers, any of our machines, you'll note that in the properties, there is one specific section that's called secondary resources. This is the one that allows us to specify for a given machine, for a given station, what external resource, whether that is a worker object or a resource object, another one of our objects available in our library, what is necessary to complete the specific tasks. And if we wanted to specify, I need an employee or a worker of category employee to come and complete the tasks, well, we can simply specify that we need, instead of a multitude of workers, we need a specific worker. And in this case, all of these properties were already pre-filled as I was playing around with them before. But what you would see is this completely blank slate, ready to be filled with all of your options. And here is where we can specify, okay, do I know what kind of specific resource I would need, such as employee? Or is there a list of workers that I could pick from? Maybe we have 3 different categories of employees and we want to save them in a list to be able to complete those actions. In our case, we have a specific one. We have our specific employee. And we can also say, okay, well, what do I need this employee to do? Do I need it to just stay there? Does it need to actually move to the station? In most cases, when a worker is required, we would want it to then move to the given location. So the move request here, which as we see here, indicates whether the worker is going to complete the action sort of staying still. Maybe it's because there's a remote control that allows it to operate the machinery. Or in most cases, we would want it to move to the node. In our case, this could be the node of the actual machine. So if we wanted to do something specifically here, or it could be an external node, somewhere else that needs to be, a task needs to be performed. So if there's a specific operation that needs to be done on this really complex board with cables and wires, etc., but it needs to go to maybe 3 doors down to a different room with a different set of machines to fix something that's there or to complete a task there, we can specify that move right here. In our case, I want the worker to go to the specific table, to the specific machine that it's working at. And so the generic syntax would be server.input. Because our objects are intelligent, whenever we use the generic server syntax, the machine, in this case turning 1, is going to know that the server syntax, that generic sentence, refers to itself. So in here, it's going to be fully aware that where I want the worker to move is the input node of the server itself, in this case, turning 1. So now, if we click run and we see all of our orders going, we will see our workers start to move to wherever we've added those worker requirements. As you'll note, in some machines, we've added worker requirements, and in others, we have not. This could be dependent on, say, the type of machinery that you have, the specifications of the task at hand, the location, etc. Because you might be experimenting, for example, with old machinery that require labor or hands-on work with new machinery that is automated. So this is a case where you might have different setups to then figure out, okay, how can I add labor to model my current system? And then what can I remove, or how can I then remove the labor requirement to experiment with a new potential future setup? And in this system right now, we have our workers going to complete every single task. In fact, you'll note that the tasks that we're performing are referencing a specific table. So we might be completing 1, 2, 3, 4, 5, 6 different operations at each given machine. If you want to know how we added this task sequence table and how we add all those different operations, I recommend going to our building blocks part 2, because we dive much deeper into that right there. But one of our questions might be, well, I don't actually need the worker to complete everything, because right now our worker is going to be going to each machine and complete all given tasks. So if a worker is required to complete at the turning machine tasks, task 1 and 2, it's going to go and be there for the entire time. But maybe we don't want it to be there the entire time. Maybe we only want it to complete, say, the first task, because the first task is the setup, potentially, of the machinery that then continues in an automated manner or in a independent manner. Or maybe at the end when it needs to maybe do some quality control, but the prior 3 tasks, the worker's not needed. So how can we add that level of detail so that only during specific tasks we're seizing the resource required or the worker required? And so similarly to these tables where we can specify the duration of the task, the condition of the tasks, and other properties, we can also reference these tables to add a worker requirement. So how does that look? Well, let's go into the second model. You'll see the same setup, the same exact machines with the same reference to the tables. However, one of the key differences that you'll note is I'm no longer utilizing the secondary resources option right here. So you might think to yourself that, oh, then no workers are going to move around. But if I click run, workers are still going. And so the question might be, well, how is that possible if we said that there's no secondary resource requirement? And the reason for that is because I have specified through the table what specific tasks need a worker. So it's no longer as soon as an entity arrives at a machine, the worker needs to go. The worker is going to be required only for certain operations. And the way that we can define that is if I open our repeat group property, you'll see right here, there's a secondary resources requirement within the task repeat group. So just like we can specify one for the server itself, we can add resource requirements for the individual tasks at hand. And just like I'm referencing our table to identify the name, the branch type, the processing time, etc., I can also reference that to specify the resource type, whether it's, again, a specific or from a selection list, and then the name of that resource. So I can now store all of that information directly inside of a server, or inside of a table, excuse me, no longer locally stored in the server. This makes it much easier than for larger systems where we might have a lot of workers, a lot of machinery, each one with its own very unique worker requirements, allows more flexibility to modify those properties. Because we no longer need to go inside of each individual server, we can just access a table. And we could even reference the location where we want that worker to move or other requirements such as constraints, specific selection conditions. How do I ensure that maybe the worker that I pick is one that has a certain level of qualifications, right? We can add all of those specific needs right here and have those potentially reference a given table. And so if I go into my data, you'll see the table is exactly the same as the one that we saw before, just with a few extra columns right here. One that is an enumeration property. I get confused a lot of the time when trying to remember what type of column or what type of property is needed to add the different sort of selection options, whether it's a specific, select from list, parent object, or even for other enumeration types. So for example, the enumeration for, let me see, material action type, whether we are trying to do a material table where we consume or produce, etc. When we want to have all those multiple options, the enumeration property is going to be where you want to look. And then the other table, the other column that we want is our object. In this case, I put it under transporter, but we can also just use whatever object or transporter we want to reference. But we just need a table or a column so that we can specify, okay, I need an employee. Now, one key thing I do want to note is when you first create a property or an object reference property, such as this one right here, you'll note that you'll get all these errors. And all of these are because there's no object reference in the row just yet. And this is because in the properties of the column right here, we have that each single row must have a non-null value. So every single row must reference something. But in our case, we might not have tasks that need a worker at all. We might want some that are null or empty, etc. So the way to fix it is a simple switch from true to false. This is just as a little note for everyone who might put up this table and all of a sudden get all of those X's and errors. All you need to do is specify that the resource, if there is no requirement that every single row have a non-null or non-zero value, you can change the required value from false to true.
Yeah.
Yes.
Let me just jump in real quick. From a sharing perspective, make sure you're sharing both your screens. I don't think we're seeing everything.
Okay, let me do that real quick then. Can you see my Simio screen?
Yes.
Excellent. And you can see now the drop down with all of the options.
Yes. Yes.
Excellent. So going back very quick for the enumeration, you'll see there's all of these different options so that when we want to have a column to reference different options for what is our wait token option. Do we want to wait for specific events, all events? If we're looking at a material consumption table or one where we want to consume potential material, material options. Do we want consume a material, bill of materials, etc.? This is the enumeration property is going to be the one that we'll want to use. But it's thanks to data tables and having a data-driven approach where we can add now for every single specific task, we can start to play around and say, okay, I only need workers for tasks, the first task performed here. I don't need a worker for all of them. And this is extremely helpful because in the previous scenario, so in the previous example where the worker would go to complete everything, that might not be representative of real life because they might only be there for 2 minutes and then the remaining 5 minutes of operations, that worker might actually be able to move around and go do elsewhere, might be able to go pick a different machine and go set it up and then come back to that original one versus just standing there. And so this allows us to model that behavior where instead of having a worker still at a specific location or seized for a longer period of time than what's actually needed, they can go and complete other tasks in the meanwhile. And so now that we've added or we've looked at how to add those worker requirements, the next step is understanding, well, how do I ensure that my worker goes on breaks though? How do I make sure that there are specific schedules that are followed? Because our worker right now is just working on a 24/7, always on shift, always ready to grind kind of schedule. But that's not realistic. Workers are going to have times where they clock in, times where they clock out, certain breaks during the day, and sometimes inconveniences are going to happen where a worker is going to get a phone call and they're going to have to leave middle of the day and you're going to have one less employee available and you might have to figure out who to call or get someone else on the available. How do we do that? But before jumping into those worker schedules, I just want to pause here and Dan, see if there's any questions that could be addressed right now.
Yeah, I'm reading through some questions here. Can multiple different resource types, such as both a worker and resource object, be seized by a server simultaneously?
Absolutely. So when we look at, for example, the server and we look at the secondary resources, you'll notice that the very first property is asking if it's a repeat group. So this is going to be the one that tells us, okay, do I only want one worker or one resource, i.e. there is no repeat group? Or if we set it as true, that way we can actually specify in this repeat group all these different resources that are needed. And we can even specify within the repeat group if we have to have all of them kept reserved. Each one might need to move to a different location, etc. And we might even specify that all of them must be available at the same time before a certain task could be performed. So for example, say you want to model the resource of a worker and the resource of an object that they need to use, a tool, such as a drill, and you only have a certain number of tools. You can't really have the worker go and complete that operation without a drill. So those are scenarios where you might model the drill as a resource, the employee as the worker, and then specify that you actually need to have both a worker or employee as well as a resource. In this case, this could be, again, your drill, move or, move to the specific node. So server put. And in those cases, then, whenever something goes in here, we're going to need both of these to be seized. And so now, if I click one and we just wait for one to hit our turning one, let's see if I can. Here we go. So something's gone here. And now what we should see is we'll see one worker move to the server, but we'll see the resource here also turn green. And this is because now we have seized both the worker and the resource. And now that this is finished, the resource and the worker have both been released.
All right, one more here, then I'll let you get back. How can we add a schedule that may not follow a specific pattern, but changes day by day with different breaks and times?
Perfect. That's actually going to be a great transition over into how do we even add work schedules in the first place. So with that, let's jump into the next model, which is where we're going to start looking at how can I add schedules. So right at the beginning of the presentation, when we looked at the properties of the workers very quickly, the first one that I wanted to notice was the capacity type, where it can either be a fixed capacity, always 1 or always 0, i.e. always on shift or always off shift, or we can specify a work schedule. And you'll notice here, if I expand on these, we can start to add, okay, what is the work schedule that they need to follow? And then what are certain exceptions, like a work day where they're not actually on shift, such as a holiday, or work periods where maybe during the given day, they might have to work from 9 to 12, but there's a small break in there that we need to add an exception for that, and they're going to be off shift. How do we start doing that? Well, if we go into our data, you'll notice on the left-hand side, all these different tabs, and a little bit further down, there's actually a work schedules. And this is where we can add both a pattern base, so one that repeats every week exactly the same manner. So when that comes to mind is the standard 8 to 5 or 9 to 5 schedule where you clock in, you have a lunch break, you clock out at the end of the day. Or if we wanted to add more flexibility, do so using a table. And with a table, we can have specific dates or add that information in each table where we specify for every day the specific time ranges where workers are on shift or off shift. But let's look at the example model that we have prepared. In our case, we're going to be looking at what happens when we have, for example, 2 different employees. One, that we want a standard schedule to be followed, a typical sort of day of work. But then we might have certain days during the week where we know we need extra help. We know that we need more hands in the system. And so we might have a second category that we're going to call overtime employees. And these are going to be employees that are only going to come in on a certain day or a certain hour or a certain time frame. And you'll notice on the right, its capacity type has now changed from work schedule to overtime. So let's go into that data tab and look at what that schedule looks like. You'll notice that I've created 3 different schedules. And as we go on, you'll see why. But the first one that I want you to notice is the standard, where Monday through Friday, we follow the typical standard day, which that is a pattern that gets followed on repeat. You start and finish always the same. And the way that we define that pattern is by adding a day pattern. So the pattern work schedule is one that gets repeated the same manner every single week. Whereas again, if we wanted to add that more flexible approach, we could use a table-based work schedule, where by creating a data table, we would define the start and end times of every single on and off shift of our workers. But in our case, we're just using a standard weekly pattern where the workers of our standard schedule, so our employees, are going to work Monday through Friday from 8 a.m. till 12 p.m. They'll get a 45-minute break. And then from 12:45 to 3:45, they'll work again, get a 15-minute break, and then work again from 4 to 6. And that's when they end their day. Whereas the overtime employee has that same standard day. So they'll have those same work hours, but only on Tuesdays and Fridays. Those are going to be the workers that are going to come in and help on the busiest days. In our case, it's Tuesdays and Fridays. In other cases, it could be Monday, Wednesday, Friday. In certain situations, that might be something that you have to dynamically assign. And we're going to look at how to do that shortly. But what that means now is if I actually look at the model and I click run, if you'll note the start day, it's the 24th of March, which if we look at the calendar, actually, let me stop that for a second. It is a Monday, which means if now we go back to our schedule, only our employees are working on Monday and our overtime employee is not available. They're not on shift. And so in fact, you'll notice that we have some workers in blue ready to work and then some in white. These are the default states that Simio assigns to these resources to identify when a resource is on shift, but idle, off shift, or on shift and busy. So green for busy, blue for idle, white for off shift. And so it's now where this worker is going to show unavailable, off shift for until the very next day, when then the workers are going to then become again, or at 8 a.m., our worker is going to go on shift. And what we can see is if I fast forward to the end of our simulation run, let's see if I can actually fast forward to a day Tuesday. Here we go. So now, since it's Tuesday, we can see that even our overtime employee down here is in blue because now he is on shift and ready to work and help however he is needed and wherever he's needed. And the way that we could select, for example, both of these workers or either is from using a select from list. So if we created a list with all of our different workers, so if we created, say, right here, a list of workers with our employee and our overtime employee, we could then have our selection, for example, whether that's in a specific task or right out here in our secondary resources, look at our select from list instead of a specific, and we can have our worker list, and that way they can pick from either only employees if they're only on shift or the overtime employee if they're available. And so now that we've added these schedules, though, the question might become, well, what happens if I want to change? What happens if I want to put a specific worker off shift? What happens if I want to have one of my 3 employees, for example, employee 2, go sick or has to take a break during the day and I need someone else to come in and cover for that shift? How can I do that? The first thing I want to note is all of this can be done. It might require a little bit of thinking. It might require a little bit of process logic, which is what we're going to be looking at. But when it comes down to it, it's a matter of first identifying the worker and then adjusting their schedule or their capacity. Their capacity is an actual function that you can reference and adjust. It's a state. So we can say its capacity, I'm going to set it to 0 to notify that it's off shift. And then I can set it back to 1 where it's on shift. And so let's look at an example model where that actually happens. So in this model, what I wanted to do is I wanted to identify a specific worker from the employee population. You'll notice that every time I begin the model run, there is only 1 overtime employee, but 3 standard employees. And this was a property that I had changed for the population property right here. This could reference a control, this could be a consistent value, this could be 1, this could be 10, whatever it is that you're trying to model in your system. But in my case, what I then want to do is, okay, I want to then be able to identify a specific worker. I want to be able to identify them individually, maybe because I want to mimic what happens if worker 2 goes off shift, or I want to be able to store the information of, okay, worker 1, 2, and 3. This is where they've been allocated, and I want to record that history, for example. Well, what we can do is, and there's a multitude of ways to do this. You can search by utilizing the actual name of the object. So you'll notice that this, for example, is called employee in the parentheses 1, employee, and then in the square brackets 2, and then employee square brackets 3. But one way that I've done it is through creating a custom worker. Now, custom objects, we've discussed these in prior Simio Solution Series presentations. Again, all of these are recorded and saved on our website. So if you haven't taken a look at those, I really recommend. But when it comes, just very briefly, when we create custom objects, we basically want to create objects or create, modify some of the pre-existing objects and maybe add a little bit of our own personal touch, whether that's defining a new set of properties as the default, or in our case, that might be creating a new state to help us keep track of all of the workers. In my case, I created a custom worker where I can save the index or the ID. In my case, I might assign a specific number, 1, 2, 3, 4. You might have a specific code that you want to save, etc., because maybe every badge of worker has a specific unique identifier that you then want to utilize, etc. And so that's the one that I then use to assign right at the beginning of the model run every single worker an index. So worker 1 gets assigned index 1, worker 2 gets assigned index 2, worker 3 gets assigned index 3. And the reason I do this is so that then it becomes easier for me to identify those specific workers. If I know that worker 3 completed a certain task and I need worker 3 to come back and do that task again, I can find him through that index. But the reason why I want to do that is because what we might want to use then is use the processes to then figure out, okay, I need to find the current worker. Say I want to find a worker of ID 2, or I want the second worker in my population, and I want to put them off shift. I want that worker to go and have a break, for example. Well, what we can do is through process logic, if I fast forward, I have this specific process where what I end up doing is I will look for that specific instance of worker, and then through the assign, you'll notice my current capacity is one of the properties. And it's a property that is of the worker itself as well. So not just of the standard work or of the custom object worker, but it's one that is actually of the worker object itself. And you'll notice that if I remove the my worker, there's no error. In my case, because they are custom workers, I want to specify that. But the current capacity is the one that we can then modify to specify the worker goes on shift or off shift. And so now, if we find worker 2, where is he? Is this one it? That's employee 3. Is this one? This is employee 2. Excellent. So what we're going to see is right now employee 2 is working. He's busy at the milling station doing something. But he might have gotten a call and needs to go pick it up. Or he might have gone busy and needs to now run away for a certain amount of time. Through that process, I can now, by assigning its capacity to 0, you'll notice that he went from green, i.e. busy, to white, i.e. off shift. So now we're going to have this worker going off shift. And they're going to be off shift until I change back their capacity. So their capacity is going to be 0 regardless of their schedule until I go and modify their capacity. Or there's a change in that schedule where that capacity goes back to being 1. In my case, I have decided through process logic, if I again hit this, that they were only going to be out for 15 minutes. Maybe this is a bathroom break that we want to model. They were out for 15 minutes and now they go back to continue the operation they had left. So they are right back where they started. Through a similar system is how we can potentially then search for other populations, such as the overtime employee, to go back on shift or go actually on shift and then go off shift when they come back. So for example, through process logic, similarly here where I can use these search steps, I can do another search step where I search for a object instance of type overtime employee. And then I can assign, just by copying the step, the current capacity to 1. And in fact, what we'll see is if I fast forward, we should see this worker turn white and this one now become busy. And we saw it do exactly that. However, one of the things I did mention was the only way that we can then change its capacity back to 1 or return its shift is if we then readjust their capacity. But instead of adjusting capacity, what we can do is we can actually, through process logic, utilize a set work schedule step where we can assign specific schedules and change them during the model run. So what that looks like is if I go into my next and final model of the session, right here, same exact setup. I have my workers, I have my overtime employee, all of those with those different schedules. What I've also created, and this might have been, this goes back to what we were saying before, is I now have my off shift schedule where I might want to put a worker completely off shift for the remainder of the day and then maybe modify or adjust other worker schedules, maybe moving them from support to standard, standard to support, standard to off schedule to support, etc. But the idea is exactly the same. We can do this by searching for the specific worker. In my case, it might be that worker 2. And I decide I need that worker to go off shift, completely off shift. So put them on the off shift schedule. And maybe I want the worker, the overtime employee, to now follow the standard schedule. The difference between changing the capacity and the schedule is because that way the worker will still follow the same break patterns of everyone else. Because otherwise, in the previous schedule, when all the other workers go on break, that overtime employee might actually still be working. At 10 p.m. when everyone's away, that overtime employee might still be working because we've assigned the capacity to 1, unless we've then modified it back to 0. But if we actually set schedules, they'll be able to follow along on those given breaks. So be able to go on break, on shift, off shift, following that very specific pattern. And so now we can see our worker going off shift. Support worker is now on shift. And we continue our model run and you'll see him continuing on. And now the schedule that they're following is the actual standard schedule. So as soon as they will go off shift, say at 12, so let's speed this up just a little bit. Might have to speed it up more. So just give it a second because at 12, they should all go on break. Excellent. Let me pause, bring this back down to 1. So now what we'll see, is now all of them are on break because they're following the same pattern that we wanted them. That pattern of you work until 12, and then from 12 to 12:45, you are on break. So these are a few ways where we can start adding these worker requirements and these nuances of, well, what is my work schedule like? What if I need to modify something on the fly? How can I find those specific worker instances and modify their schedule, their capacity, adjust what they're doing, etc. So I hope that this was helpful, and I'm happy to answer any other questions that have come up.
Great, thank you, Kiara. And we do have a few questions in the queue. If you haven't had a chance to type your question in, you should see the Slido bar somewhere in your WebEx toolbar. Type your question in there and we can ask it. If you don't have a chance to ask it or you want to reach out directly to us, I'll put our email addresses up here at the end. All right, Kiara, a couple questions that we have. How do you consider task efficiency of hold on, my things are shifting. How do you consider task efficiency of a veteran worker versus an apprentice level worker?
Absolutely. That's a great question. And that's definitely something that needs to be considered whenever we are modeling specific tasks. Because if there's an intern that is doing a specific task, they might take a little bit longer than someone who's been there for 10 years and has done this on repeat over and over again. And so the way that we can do this is it's not necessarily something that we can modify on the worker instance itself. Because we might want, for example, say we have 3 workers of category employee, but each one might have a different experience or different skill set. Well, what we can do is similar to how I've created an index, we can then use something, another property, maybe this index, instead of being indexed, it could be experience. So experience 1, 2, or 3. And then in the actual servers and in the tasks, you'll notice under resource requirements and under, where is it? It's right here. Under required quantity constraints, there is resource efficiency. This is going to be the value that you want to play around with to model workers that are more or less efficient. And you can actually reference the worker that you're seizing. So you might want to specify, okay, I need, for the selection condition, I need a worker with a minimum 3 years of experience. So that could be a selection condition right here where you search for your workers and say, okay, that worker.index, that worker.id, that worker.experience, whatever that property is, must be above a certain value. And then use that as well to reference here in the resource efficiency. What this is it modifies the rate at which a specific task is performed. The default is 1. So what that means is if the task is supposed to be 5 minutes, then with a resource efficiency of 1, the worker will complete the task in 5 minutes. But as we modify this, so if the we want the duration to be longer or shorter, we want the the efficiency to be larger or smaller. So as we say right here, an efficiency value greater than 1 shortens the time, and a value less than 1 lengthens it. So say we have a worker whose experience is 2, they're going to be able to complete that task instead of in 5 minutes, they'll complete it in 2.5 minutes. Whereas if the capacity or the resource efficiency is 0.5, it's going to take them twice as long instead of half the time.
Perfect. Can workers be used to move entities between stations, or can only vehicles do so?
The worker can absolutely move it. In fact, the worker in and of itself is also considered a transporter, just like the vehicle object. And the way that we would add that is at the specific output nodes, so the little blue nodes, output or transfer nodes, we can specify the routing out sort of in the routing logic, or in the process properties, transport logic, where if we set this as, true or always or conditional, i.e. we always need a transporter, or, we might need it based on a certain condition, whatever that may be, we can specify the transporter be an employee, or be a worker, or be a vehicle, etc. So just like the workers can be seized to complete tasks at hand, they can also be the ones in charge of moving objects around.
Perfect. All right, will changing a worker's current capacity have an impact on the worker's utilization rate?
So the utilization rate will take into consideration when it's how long it's idle when it's on shift. So putting that worker off shift will, I guess the question is, or the question that I would want to understand is what the person that's asking this means by impacting it. Because if they go off shift, then they're technically not supposed to be working, so that it's not going to decrease their utilization rate, if that's the kind of question that they're trying to ask.
Okay. All right. Worst case scenario, if we didn't answer your question there, like I said, I'll be flashing up here on my email addresses here at the end of the session. You can always reach out to us directly. All right. What happens to the task at hand if the worker goes off shift? Does the task restart its processing once the worker returns on shift? Can we change worker if one goes off shift? I think you answered some
Absolutely.
of those questions throughout the session, but there might be a little bit of repeat, but let's see.
Yep, no, absolutely. So the way that we would specify what the behavior of the task at hand is fully dependent on the machine itself. And there is this off shift rule that allows us to specify, okay, what do we need for, or what do we want to do if our resource goes off shift? And you'll notice there's a couple options. The first one is suspend processing. And what that means is the worker is going to just go away and the processing is going to be put on hold. So when the worker goes back, say it was supposed to process for 5 minutes, but it only completed 3 minutes. When the worker goes back on shift, then it'll only process for the remaining 2 minutes, not the entire 5-minute original minutes. The other option is going to be finish work already started. Now this, going back to the previous question, will actually impact the utilization rates because the worker is going to be busy, but technically off shift. So that is going to actually, sometimes that's why we will see utilization rates above 100% because they're actually getting used when they're not supposed to be because they are technically off shift, but they might still be working.
Perfect.
But going back to the last question, then yes, this is how you would modify when a worker goes off shift and decides to, leave the machine. That operation does not, doesn't restart from the beginning. It'll just pick up where it left off.
Got it. Okay. All right, let's do one more question, then I'll bring up our email addresses and then we'll wrap up. So can you add certain certificates to each worker that allows them to do work on a specific machine? For example, only a worker with a certificate can work on the milling machine.
Absolutely. So the way that you would add that is whenever you have a specific resource requirement, you can specify a specific selection condition. So only workers with that specific requirement, only workers with a certain number of years of experience, et cetera, can only be selected. So this allows you to basically filter down and only have certain categories or certain types of workers, et cetera, be able to complete that specific task. And this becomes really important in a lot of, for example, manual hands-on operations where you need someone with more experience or more qualifications, for example, to do that, because not everyone might have the same skill set or qualifications to complete certain tasks. And so it's in the selection condition where we can add those requirements and those specifications to ensure that we only select the workers that we want.
Great. All right, thank you, Kiara. We are just about out of time to just grab the screen back here and share PowerPoint one last time here. As I mentioned earlier, this is our email addresses, both myself and Kiara. So if you want to reach out to one of us directly, feel free to write those email addresses down or copy them off the screen. If you didn't get your question answered today, or if you asked a question, I think we addressed all of them, but the one question that might have been partially answered, if we didn't answer it fully, feel free to reach out to us directly. Once again, that's the end of today's session. Let me just go one more time. I mentioned earlier on, we will be announcing our fall schedule shortly. Be on the lookout for a September, October, November schedule in the upcoming weeks. We will be back in 2 months. Thanks everyone for attending. If you want to go back and watch this on recording, just go to simio.com and look for the resources tab. You'll find the training on there. Thanks again for everyone for attending, and we'll see you in hopefully 2 months. Bye all.